when you start out a problem like this, you take the information that they've given you and you draw out a picture. So I'm going to take and draw out what beta looks like. Well, I know beta is between pi and 3 pi over 2. So that must mean that it looks like something like this. So here's my angle, beta. It has, let's see here, it's got a cosine value, this left-right run, it's got a cosine value of -4 over 5. So we're going to go -4 here, and we're going to go 5 here. You could put -4/5 here, but then you have to put 1 here for the hypotenuse. And that's as if you're going to put it on the unit circle. Excuse me. Okay, now to use these formulas, okay, we don't really need to know anything about sine, because if you notice, the formulas that we've got written down for the half angles all involve cosine. But let's just grab it anyway. So let me grab my, so this is for the beta angle. It doesn't ever hurt to put down extra information. So for beta, the cosine of beta, we're already given that, that's -4 over 5, adjacent over the hypotenuse. The sine of beta is the opposite. Well, that's this length right here, which is 3. Now how did I get the 3? Well, I did this. I did -4 squared plus, we'll call it y, is equal to 5 squared. So that gives me 16. Plus y squared is 25. So y squared is 9. So y equals plus or minus 3. So we know this length is 3, right? Question is, do we do positive or negative? And the answer is we're going to do negative because we're heading downward. We're in quadrant 3 over here. So it's going to be -3 over 5, which will also give us a tangent value, okay, of, let's see here, 3/4, because it's opposite over adjacent. So it's going to be a negative over negative, and you make that positive. Okay, now what are you gonna do here? Well, the next step, we'll do this guy first, is to determine what is the sine value of half that angle. Well, where does half that angle fall? If this guy falls in quadrant 3, then half of that guy, so let me write it up here. So if this is true, then half of beta has got to fall between pi over 2 and 3 pi over 4. So here's pi over 2 and 3 pi over 4. If you do your divisions, here's pi over 4, 2 pi over 4, 3 pi over 4. So that guy's going to fall somewhere up here, it looks like, in quadrant 2. So we should be able to check when we get these answers out whether my logic's correct or not. So the sine of b over 2, now here we don't know what the actual angle is. And there's ways to find the original angle. So we can't, here I'll write it out. Right now, it's this guy that's the problem. Because we don't know what's going to happen here. Okay. The only thing that we can tell you is that since our angle beta over 2 has to fall between pi over 2 and 3 pi over 4. Let me draw 3 pi over 4 on here for you. So here's 1 pi over 4. 2 pi's over 4, which is pi over 2. And here is 3 pi over 4. So beta over 2 falls in this range. So clearly sine is positive. So this whole mess out in front, I'm going to ignore it for right now. So let's cross this out, because we don't have the actual value for beta. So what we're going to do, and I probably should have written just to be a little bit more precise, probably should write it like this, even though I bet you no one caught that. This is going to be beta, and this will be beta. So I don't know this guy, but I can get a pretty good idea of where it's at by using this restriction. So let's complete this. This is sine beta over 2 is equal to, this is what we're looking for, the square root of 1 minus the cosine of beta, which is negative 4/5, divided by 2. So it'll be 1 plus 4/5 over 2. So this will be 5/5 plus 4/5 is 9/5 divided by 2. That's going to give me the square root of 9 over 10, which is the square root of 9 over the square root of 10. And that's 3 square roots of 10, which is 3 square roots of 10 over 10. Okay, let's try the cosine value. So cosine, let's write that down in, let's do that in orange. So I'll do it right here in the middle. So the cosine of beta over 2 should be equal to, again, negative 1 raised to beta plus pi over 2 pi times the square root of 1 plus the cosine of beta over 2. This guy we're going to cancel out because we clearly don't know what beta is, so we really can't do any computation there. However, we know that beta over 2 is going to have to fall in quadrant 2, which means at that spot, the cosine of beta should be a negative value. So we're going to make this guy negative 1. So let's plug what we know in. Cosine of beta again is negative 4/5. Okay, and that's over 2. So negative square root. This is 1 minus 4/5, which is just 1/5 over 2, which will be 1 over 10, which will be negative 1 over the square root of 10, which will be negative square root of 10 over 10. Now there's a formula for the half angle for tangent, and you can go out and look it up, and I believe I give it to you in one of the worksheets in class, but we don't need it for here because we have sine and cosine. So let's do this in this color over here in this bright blue. The tangent of whatever beta is divided by 2, so the tangent of half the angle should be equal to the sine of half that angle divided by the cosine of half that angle. And we know the sine is 3 root 10 over 10, so we're going to divide that guy by negative root 10 over 10. which is equal to 3 root 10 over 10 multiplied by negative 10 over root 10. These guys flip spots. So this cancels with this, and this cancels with this. So I have a negative here and a 3. And so I get negative 3, which, if you notice, that should make sense that tangent is negative up here in this quadrant.